okay. And then we will start. So how about let's do this first. So what we will do today is we will start with new chapter, okay? New chapter, hold on, let me get this a little bit of larger probably. Hold on, let me admit all. Hold on, I need to get admit. So can everyone see my screen?
Yes.
Yes, okay. So if you recall, so today we will start with, so in our textbook, it's chapter 21, okay? So we kind of move it back and forth, okay? So that's my understanding of the arrangement of chapters, okay? And if you recall in CS, hold on, let me get to the student. And if you recall, in CS2, we learned part of Java collection framework. It's a very useful framework as it deals all sorts of data structures, okay? And if you recall, basically, collection also use iterable as it interface, and the collection is also interface. So collection interface provide a number of general methods. We can do add, we can remove, something like that, is it? And under it, I remember we already learned list interface, if you recall, and the queue interface, is it? And the queue is first in, first out. Is it? And the list, the good thing for it is can insert anywhere. Insert or delete. Is it? And the DAC we also learned. Is it DAC? DAC, so it's also interface. So DAC is a double-ended queue. Hold on. I need to first close this, admit, and then restart. So double-ended queue. And if you take a close look of this hierarchy, you will see all of this left are interfaces, is it? And we already learned this part. And there is one other interface we haven't learned, so it's set. Okay, so that's what we will learn in our chapter 21, okay, a new data structure. Okay, and under it, if you see the hierarchy, you will see it, the sub-interface from set is sorted set. Okay, and from sorted, you can have sub-interface of navigable set. Okay, so anyway, so that's all regarding set. So it's another kind of data structure, okay? And we basically haven't to deal with abstract class a lot, is it? But in the in our CS2, we also learned the priority queue. That the priority queue you can clearly see is from queue interface. And we also learned the linked list. That linked list on one hand, it's from the DAC and the queue. Did you see? So linked list, is it? On the other hand, it also has features from list. From list, is it? So that's linked list. So basically that's why in Java, whenever you want to use the queue data structure, basically you create a linked list, is it, to achieve your goal. And we also learn array list. Array list, it's very, very efficient, okay? Because it's kind of have the benefits. of array, is it? It supports index, and on the other hand, it also dynamic grow, as you can insert and delete anywhere. So that's ArrayList is quite useful. And we also learn stack. So stack is LIFO. So last in, first out. So that's, or this part we already learned, kind of. Is it? For this part. And we haven't learned the set related data structure. But I remember Tuesday we discussed a tree set. Is it? So tree set it's more related with binary tree. Binary tree, okay, but it belongs to the set data structure, okay. So for the set data structure, the concrete class that's related with the set data structure is the tree set we already learned, is it? So it's basically because of the binary tree, the binary search tree, it's ordered. So it has a lot of features also from binary tree, is it? It's based on the in order to arrange the set. And we will also learn two other concrete set class, hash set and linked hash set, okay, today. So anyway, so that's our focus today. We will learn this part, the set related, okay. Okay, so that's regarding this hierarchy. Probably let's also quickly go over the next slides, what it discuss. Okay, so we already kind of familiar with this. Is it the collection, Java collection hierarchy? Is it? So it's from iterable, and the iterable then support the internal for each loop, is it? And the collection most used operations method, add all, as it contains, equals, and remove all, retain all, as a two arrays, all of those. But all of those are abstract method, okay, because it's interface. That depends on individual concrete class who implement and have their own implementation. Okay, so this is just a kind of review, okay? And that's what we will start to learn in this chapter. It's about set interface. So what is set interface? Okay, for list and queue. Okay, both of this we already learned. They allow duplicates. Okay. But set, okay, set doesn't. So set contains no duplicate elements. Okay, and if you recall binary search tree, it's also unique, is it? Each node is unique, okay, when we arranged. So in binary search tree, the key is also unique. Okay, so the basic idea set, basically it's kind of from math. So in math, you also have the set concept, is it? And the set doesn't allow duplicate, so no duplicate. So that's the feature, okay, for set, okay, for set. Because of this, so it says there is no two element can be in the set. So if you use the equals, is it for two elements from the set, that's not going to happen. Okay, so that's the unique thing. So for set, the major thing is no duplicate. And because of no duplicate, it's not like a list and a queue. Order is important. Is it the order? You insert the order, you add the order is important. And set doesn't care. Is it in math, you kind of just draw and So they can all just be dropped in anywhere. So it doesn't matter too much regarding order, regarding order. But of course, like the tree set, we still have kind of like ascending order. That's because the way we arrange it. Okay. So anyway, so the basic concept for set is no duplicate collections. Okay. And then next, let's see. Okay. So then regarding set hierarchy. Okay, hierarchy. So generally speaking, set we have two different kind of set. Okay, one is from the abstract set, abstract class. So these two are concrete classes. Okay, it's a hash set. Okay, the other one is called linked hash set. Okay, and as to the word of a hash, later on, we will also learn in much more detail, okay, about a hash in one of the chapters. So what here the hash set is going to arrange the set using certain hashing scheme. Okay, and the hashing you may already, I remember in CS2, one of the lab we did with linked list, if you recall. And one of the lab we do with the module 11 or module 13, if you recall, etc. And then you have an array of linked list, etc. So it's kind of list one, list two, something, etc. And for each of it, etc. So it's kind of corresponding to the elements of the array, but each of it, it's a linked list. It's a linked list, and each of it is a linked list. And how do you find the corresponding one? If you recall, you use some module operation, So basically over there, that is one of the simplest case for hashing. Okay, so that is one way to do the hashing. Okay. So anyway, so hashing, the idea is you apply some operation on some objects. Okay, then you will get some fixed size value. Okay, that's, so over here we get some fixed size. It's the module of 0, 1, 2, 10, or like 0, 1, 2, 12. Is it? Hold on, let me get the student in. But anyway, so it's through some operation, anyway, you can generate some value, okay, fixed size value. And then with that, then you can kind of map to somewhere that you are going to use to store, is it? So that's why this hash set concept more kind of using hash table. Okay, so this kind of idea, we call it a hash table idea. Okay, so the hash set is going to kind of use a hash tables idea to store all of the set items. Okay, so that's a hash set. And the linked hash set, so it's linked like a linked list. Okay, so it uses hashing, okay, but it also consider the way, the order that you're going to insert to the collection. So the order that you add the item to the collection also matters. Okay, so this is this category of set. This category of set. And on the other hand, we also have another category. Okay, we already learned the tree set. is it, in our last class. And if you see the hierarchy, you will see the tree set. On one hand, it's from the abstract set. So it has part of the features from abstract set. And on the other hand, it also inherit from what? From sorted set and the navigable set. So based on the name of the interface, sorted set, so that means the collection is going to be arranged in some sorting order, is it ascending or descending order, is it? So sorted set. And the navigable, so that means you can iterate, is it? You can visit, is it, one by one, so navigable set. So it has both of the features from this. So that's the tree set. But anyway, we already see the example. So it's an ordered set, okay? So if you want your set to be stored in certain order, then you can pick tree set, okay? So the idea is when you wanted to store a number of items in a set data structure, then you need to determine among these three concrete set. This is three concrete set. Okay, 1, 2, 3. So hash set or linked hash set or tree set, then you need to determine your application. So focus is on the order, then probably you pick a tree set. And or you just want to do some quick searching, then you can use a hash set. Or if you also care about your insertion order, then you can use the linked hash set. Okay, so it depends on your focus, the concentration, then you can pick either, you can pick one of them, okay? And hash set, because it's based on the concept of a hash table, is it? So generally speaking, for hash set, and for all of the set operation, generally you have add, you have remove operation. So this also common to collection, is it? And contains. Contains mainly is regarding searching, is it? So for all of this, because the concept is based on hash table, so generally speaking, their time complexity is constant, is order of 1. Okay, order of 1. And for tree set, because it's arranged in a binary tree, is it? So regarding those operations, and generally speaking, it's order of log 2n. Okay, so that's regarding the general operation, their time complexity, okay. Okay, so we kind of have the big picture, is it, about the set, hash set, tree set, linked hash set. And I already kind of explained all of those. Okay, let's see. Maybe we will come back to see their examples. Let me see if there are any concept. Okay. Okay, and I can stop discussing about that. And next, let's take a look my example, okay, to have better understanding of all of the set operations. Okay, so over here, for this example mostly deal with the hash set and the hash set way, okay. And this example, I have 2 Java files. I also have a book class, okay. So let's probably first take a look at that book class. Then we are going to store a number of books in set. So here is our book class. So we have a book and it's support deep copy clonable. And the book has 2 instance variable ID and name. Okay, so quite straightforward. And then let's see. And then we have the corresponding get ID, get name, and the set book, and the clone, nothing new. And the toString return ID and name, etc. And we also have the equals method. The equals method, then you need to make sure both ID and the name, okay, are the same. And here it also has a hash code method overwritten from object class, okay. So we are going to hash based on both ID and the name, both of the instance variables. Okay, later on we will learn in more detail about hash code. So anyway, so it does some kind of a hash operation. Okay. So generate some fixed set. And here we also have, and I don't think we use this, okay. But anyway, so here it defines some comparator, okay, regarding a book, okay. So this is the book class. So we kind of have some idea. So then next, let's see for the book, okay. And here we first create a hash set. Okay, hash set. So like I previously explained, so hash set is a concrete class. So basically, whenever you want to use set, there are 3 concrete set class you can pick. So hash set is one, is it? The other one more related is linked hash set. And the other one we already learned, is it a tree set? Okay, tree set. So tree set more related with ordering. Is it linked is regarding insertion order? Insertion order, okay. And the hash is just using some hashing to basically organize it. Okay, so anyway, so hash set is said it's backed by hash table. Okay, and so because it's a hash set, so it doesn't guarantee the iteration order of the set. So it's random. Okay, so it's a kind of like you just drop it in a pie. Okay, so there is no specific order. Okay, and for the set, if you want to add a new item to the set, you just call add. So here I add different books. Each time it's a different book. Okay, and if you have 2 books exact same, that will be only added once because set doesn't allow duplicates. Okay, and over here I also going to print out this set and we will see. Okay, so that's the hash set. Okay, so and the second set, ST2, is a tree set. Okay, tree set. And also because of the tree set, because it's a tree set, so you need to specify the comparing order. Is it you want to use either comparable interface or you want to have the comparator? Is it comparator? So over here it says, okay, I will let this tree set. So the tree set is for book. Is it? It's regarding book. So regarding the 2 books, what kind of order I'm going to base on? I'm going to use their name. Okay, use their name for the ordering of this tree set. Okay, and based on name, then definitely like it follows here, it's ABC. Is it ABC order? And So that's regarding tree set. Be careful. Each time when you create a tree set, you need to specify. Otherwise, it will go with the default order, the comparable interface that you defined. If you don't provide that, we'll just go with whatever the default one, is it? And here, based on the name, so it will just based on the name. So name basically it's a string, so it's based on the lexicography order. Okay, so you're going to have these 3 books added to the second set. Okay, and we will also print them out. Okay. Okay, so that's regarding this second set is a tree set. The first set is a hash set. And then, let's see, then the first set, they call it add all method to add the second set to the first set. Okay, so that's also allowed. So you can add another collection to a set, is it? And if there is any duplicate, it won't be added, is it? And we can also see this set, okay. Okay, so now we have 2 sets, is it? Let's run this program to see what the first 3 part we will have, okay. So let's go back to see. The order we add is 111, 131, 120, 151. Is it kind of that order for the first set? And then let's see the output if you take a close look. The output, so not in the order of insertion. Is it not in the order of insertion? But for the second one it's a tree set. Tree set, is it? So it does follow the order. So ABC, is it? ABC order. And the third one, the basic is the first one. You add the second 2. So we call that add all. Is it add the second set to the third set? Is it? If you take a look, the output result, you will see there is no order. Is it kind of very random, rearranged? Is it rearranged? That's because the first set is what? It's a hash set. So hash set doesn't preserve any order. Okay, doesn't preserve any order. Okay, so we kind of see the hash set. And then let's take a look more, okay? And then over here, if you take a look, we create a new book called B0, has 111 ABBB. And then we add it to the big set, the hash set, okay? The hash set. And let's see. The ST original, it also has 111, but it's BBBB. Is it? So the 2 book name are different, even though they have the same ID. Is it? But here, for the set, it's regarding book. So it will consider this as 2 different book, okay? So both of them will be added. Will be added, okay? And then, let's see, what next is check. Is it, oh, hold on, let me, so we add the book 0, it's 11 ABBB, this book, is it? So that book supposed to be in the set, is it? So how do you want to check if the book is in the set? So it calls the contains method. Okay, contains method. But here, did you see, we create a new book. Okay, so what contains use the equals and hash code to check. Okay, so it doesn't care about the reference. It just uses the contents to check. So if the contents contains that, then it will think it has that item. Okay, and here, because this basically, this is B0. So this checks basically, this is a reference. This is a copy, but you will see both give returns as true. Okay, both returns as true. And here it also checks if another set, you can also call the contains all, okay, to check. And you can also check if two sets are the same. Okay, and all of this is regarding the contents, okay, not the reference. Okay, we will see that. Okay, and then let's see the running result regarding this part. Okay, we have this book, is it? That book is 111 and then ABBB, is it? And it calls the contains to check, did you see it return true? And if you want to check exactly that book, it also returns true. Is it? So both return true. And does ST contain the second tree set? It says yes, because all items in that. Is it? And are both set the same, equal to each other? No. Is it? So we did get no. And over here, this contains method. The time complexity is constant. Okay, it's constant. So you have this whole set. Hold on. So basically you have this set, is it? And of course, it's also going to have that other 111 ABBB, also maybe somewhere here, is it? So anyway, so that item is also there, is it? So it, the contains method. Contain method, so far what we learned, then you need to do one by one comparison, kind of, is it? So over here, doesn't, it's order of one, is it? Order of one, why it can do this fast location? It's because of it using hashing. Okay, using hash table concept. So internally, it already has some kind of mapping. Okay, so that's why you can quickly find it. Okay, find it. Okay, so anyway, so just be careful. Okay, here this is going to be the time complexity is the order of one. Okay, and for set, you can also loop through it, because anyway, it's from what? It support, it comes from iterable interface, is it? And then you have collection. And then you have set. Is it? So that's why you have this iterator method you can use with set also. Is it with set? And then because you get the iterator previous we learned, then you can call has next and next to get each individual item. Is it? So we can also loop through one by one. Is it? So let's take a look at the running result. Yeah, so over here, this is the running result. Is it? And if you compare, this is a set. And of course, we later on, we also add B0 somewhere, is it? But if you compare, you can see, is it? When you loop, it's one by one, is it? And then next, and next, and looks like this is add at the back, is it? So it does add one by one, is it? Oh, not add one. It does loop through, is it? So traverse one by one, is it? So here we call it iteration. So you can also use iterator to loop through a set. Okay, so it's also supported. Okay, and then next, let's see, let's take a look more. Okay, so the next one, what we are going to do is we are going to have a sorted set. So you can also declare a variable sorted set. The type is sorted set. And then you are going to assign with the tree set. You cannot do new hash set, that won't match, is it? But this works because sorted set is the super interface, is it? So tree set implement sorted set interface. Okay, so this works. Okay, and then same thing, this time for your tree set, you arrange with name. Okay, and then you add the previous st to this tree set. Okay, to this tree set. To this tree set, and then you want to get the first item, the last item of this tree set, is it? And then we also want to output this sorted set so we can see if the set is sorted. Okay. So let's take a look. This is the original set, is it? So not sorted. Not sorted, is it? And after we, so then we assign it to a tree set. To a tree set, is it? And the output for the tree set, if you take a look, it does arrange it in the order, is it? The strings lexicography order, is it? So that's why when you want to get to the first item, it's the first item, the last item. So it does get rearranged. Okay, rearranged. Okay, so anyway, so this is for the sorted set interface, the sorted head interface. And then let's see what the B0 is. I kind of forget. B0 is 111 ABBB, okay. B0 is 111 ABBB. Okay, this is B0, is it? And for sorted set, here we create another sorted set type of variable, is it? We call sorted set sub1. And then from the other sorted set, you call the head set, is it? And you specify with B0, is it B0? And then here's that the output, we can see what it contains. Okay, let's see. So this is regarding head set. Okay, head set has it's a method for sorted set. Okay, so the first subset. Let's see the sorted one. So this is our sorted one. Sorted one, is it? So this is that B0. B0, is it? And here we call the head set of B0, is it? And let's see what we get. We get, looks like we get all of this part. Is it? Head set. So this tells us the head set returns all of the items that are ahead of whatever you specify, but doesn't include, that doesn't include it, okay? So that's what the head set returns. And then next, let's take a look at the next one. The next method is tail set. Okay, tail set still with B0. Okay, and the next one is subset. You specify 2 items. You want to get the subset within the 2 items. Is it? So let's see what we have, the running result. Okay. So the first subset, so regarding this is our whole set. Okay. So this is B0. Is it B0? So here is regarding tail set. Is it tail set? And for this tail set, what we can see is kind of you get from wherever you specify all the way to the end of the set. Is it? So that's what the tail set get. Okay. And the third one is a subset. Is it? Subset is you specify the 2 items and you're going to including all of the items between the 2 one. Is it? So that's what we get is B0 and all the way to BBB. Is it? So that's regarding this 3 method. And the B1, let's take a look at B1, B2, is it? Where is B0 is 118B, is it? And where is B2? Where is B2? Where is B2? Oh, okay. B2 is here, as it is a sorted set, the last item, is it? The last item. And then here you want to get between B0 and B2, is it? And where is the sorted set? It's kind of. So this is B0, is it? And this is B2, is it? So you want the third one is subset. Is a subset of B0 and B2, is it? So this is B0 and this is B2, and you can clearly see it's get of the item from B0 to not including B2. Okay, so that's the subset. Okay, so we have learned the sorted set related method is head set, tail set, and subset. Okay, and what next part shows is that because there are a couple of interface, is a sorted set, and then we also have navigable set interface. Okay. So the following call most related with navigable set interface. So this time we still create our tree set that is a navigable one this time. Okay, we assign it and then we add all of the items. Is it? And this time for the navigable, it has some method called ceiling, flooring. Is it? And then let's see next one. What over here at the core? Okay, so then you are going to have the items returned. What is ceiling? What is floor? Is it? And over here it also shows us the navigable set of the books. Okay. And we also have the method related with navigable is a higher and a lower, and then you specify the book, okay, regarding higher and lower, okay. So let's see what we will get, okay. The running result. Okay, the running result, okay, so let's see here. Is it here? And so this is, I remember this is the original tree set, is it tree set? And the ceiling is regarding, so hold on, okay, let's go back to take a look, what's the ceiling? The ceiling and the flooring, it's book 350 YYY. Basically, if you recall, both of these two books doesn't exist in our set, is it? But you want to call the ceiling and the floor based on this non-exist book, is it? So anyway, it's some YYY, is it? Okay, so let's see. So this is our book. No, this is a sorted one. Let's see, do we have, yeah. This is sorted, is it? And sorted with what? With the string order, is a lexicography order. Okay, and here we call the ceiling. Ceiling is based on 350 and Y something. As it doesn't exist in this set, is it? And what it return, if you see, for the ceiling is 131 AAA, is it? So what this gives us, because this 350 YY, it's basically, it's kind of should after the 221 CCC, is it, if it's exist. And it should be ahead of 131 AAA, is it? So that's why this is a ceiling book, is it? So that's the, so the next one in your order, is it? In the order that's getting the most close to this 350 YYY, is it? That's why you get this one. And the floor, is it? Floor, if you see, you get this one, is it? That's what, that's the lowest one that's going to be ahead of this, is it? If you do have that one in there. So that's why this one is the ceiling and this one is the floor, is it? The floor. And oh yeah, here is, anyway, it's that navigable set, okay? And then next we also have a higher and lower, is it? And the higher, lower, let's see, what do we use for higher and lower? For higher and lower, we use a different 131 AAA, okay? For higher and lower, we use 131 AAA. Is it? That's what we use. Okay, what we use. So higher, if you see the result gives you what? Gives you this, ABBB. Is it? And it's what? This one is the one you're going to use it as kind of like the boundary. Is it? Higher, so that's what the higher returns. Higher returns, okay. And the lower, then lower returns this one. That's a lower, okay. So kind of like the ceiling and the feeling, but floor, but not exactly, okay. So you need to determine when you use ceiling and the floor and when you use a higher and lower, okay. But you can use all of them from navigable set, okay. So both of those from, and of course the tree set itself also has all of this method because it implements the interface, okay. And what next one is, in tree set we can also call the descending set method, okay. You can also call the descend, and we will see. And you can also call pole first, pole last, okay. You can also do the remove, okay. And then let's see, after we call off this, what do we have? Okay, we call higher and lower, is it? And then this is a reverse view, is it? You can see clearly it's arranged in a reverse order, is it? And the first and the last, you can also get from the original, is it? And the navigable, because we call remove, is it? You call remove and pull, so they removed, is it? They are removed and some other items. So that's why after you call remove, they are not in the set anymore. This is a set. The original set is a hash set. Okay, so that's the hash set. Okay, hash set. Okay, so anyway, so over here, we saw all of the set related method. Okay, related method, and the last two small section of code just also shows for set also you can also convert it to array, because anyway it's collection, is it that two arrays from the collection interface. And so over here, if you call the set to array, you are going to get an array. Is it going to get array? And because you get array, you can do the for each loop. Is it get access with each one of it? Okay. And what the last one try to show, and this is quite nice. Okay. It's kind of you know, more functional operation. Okay, and a very succinct or concise way to write a single statement, but with multiple tasks. Okay, so Java collection, you can convert it to string. So for any collection, if you call the data string, it will convert it, the collection, to string type. Okay, string type. And because of the string, then you can apply some filtering work on the string. Okay, and the filter will return a string. Returns a string. Okay, so what a filter method take in is some functional interface called predicate. Okay, so anyway, it's some functional interface. And who still remember functional interface versus general interface? Any special thing about a functional interface? Who still remembers?
It has only one abstract method.
Yes, very good. So it has only one abstract method. Because it has only one abstract method, is it? And basically, if you read its document, you will find it's called a test method. Okay, and that test method will do kind of this kind of like some query work. Okay, so database query. Okay, so kind of. So anyway, to apply some condition, filter out not match items, just keep whatever meet the condition. Is it? And it has that single method. That's why over here, if you take a close look, this is what? This we apply a lambda expression. Is it? What does this lambda expression apply? Okay, anyway, the E is the item from the string, is it? So an item from the string, and based on what? Okay, you will. So anyway, in this case, it's going to be, because it's a set of books, is it? So each E is a book, is it? Because it's a book, you can call the get name, is it? Get name will return a string, is it? And with string, then you say, okay, I wanted to find the string who starts with capital A. But I don't want, what I want to collect of the items is of the book name doesn't start with A. If it doesn't start with A, then I'm going to put all of this into a new string. Is it into a string? And then for the string, then I call for each method again. Okay, and for each of the item, I just going to output of the items. Is it? So over here, it just shows the collection. And this is used a lot in Java, okay, especially with professional coding. In the future, if you work, when you move to work and you write your code, you're probably going to see this a lot. So anyway, it's a collection and with a string. Okay, and the benefit for stream you can see, because if we don't use it, then we need to write quite a long code, is it, and deal with each one of the if else, is it, and then do quite a number. And this is also, you kind of see it's kind of pipeline processing. Is it? That's why we call it stream. Is it to call it a string? Okay, you can kind of pipeline and align all of the tasks together. Is it? And then one by one, and it goes through the pipeline. Is it to deal with it? Okay, and mostly what it's benefit for? It's for collection of item. Is it? And aggregation. Is it? Because over here you kind of then aggregate. You can also do count, do sum, do average, a lot of other tasks. Is it? Okay, so this just try to show, okay, with set, we can also apply a stream operation and aggregation. Okay, and it's quite useful. Okay. Okay, so I finish this major example about set. So in this chapter, basically, we finish half, and another next class, we are going to discuss it about a map data structure. So so let's just next is going to take a look at the official Java official document about set. Oh, sorry, I got to the wrong share. I need to share. Okay, let's take a look. Okay, so let's take a quick look about this. Today we learned the set. Okay, so just keep that in mind. Okay, set is an interface, and under it you have three concrete class. That linked hash set, tree set, and hash set. That's the three concrete class you need to use. Is it? And sub-interface, today we learned is a sorted set and a navigable set. Is it? Okay, so let's see the set. Over here it said the set, basically it's still collection. Is it? No duplicate elements. Okay, what that means is it doesn't, so if two items, E1 and E2 meet the equals, then you cannot have them in set, okay, in set. So basically it said it models mass set abstraction, okay, abstraction. Okay, so this is the general description about set. And the method for set is so this is add all. just like a collection that contains or equal hash code is empty, iterate will remove or return size. Is it true array? Is that we saw of that? Okay. Okay, so this is regarding set. And next, let's take a look, sorted set. Okay, sorted set, we just said it's from set, the super interface, it's set. Is it? Set. Okay, so what this sorted set is it's a provide ordering. As a provide total ordering. It can use their nature order. Is it nature order what we define as a comparable interface? Is it? Or you can use a comparator. Is it? You define. And today we saw the example. Is it? We saw the example. And what is the method it has? Is it has comparator. You can return. It has the first. We saw the head set. Last, we saw of the subset, tail set. Is it? We saw of that. Okay, so this is regarding sorted set. And then the navigable set. Okay, so let's take a look, the navigable set. So navigable set, what it says is, it's extended with navigation method. Is it? So that it report closest match for some given search targets. Like we already see, is it like lower floor, ceiling, higher of those. And it also support descending set method. Okay, so that's regarding navigable set. Okay, navigable set. And here it shows is we also see the example ceiling, descending floor, head set as a higher iterate, lower as a pole, subset, tail set is all of this. We already saw that, okay? And what next one is a hash set, is it? So hash set, let's take a look. The hash set, so it implements the set interface like previously I explained. It's backed by hash table, okay? And it doesn't guarantee iteration order. Is it iteration order? So as I also explained, is it? So the time complexity for add, remove, contain those, is it? Is constant. Is it? It's because it's using hashing. Because later on we will see, okay, once you have hashing, you can directly locate it. Okay, just like the kind of like array that you can directly locate it. Okay, so this is regarding hash set. Okay, and the last one is linked hash set. So for linked hash set, it says hash and linked list implementation of the set. So it kind of combine both, okay? So it says with predictable iteration order, okay? And it says it differs from hash set. Hash set use a hash table, is it? But for linked hash set, it maintains doubly linked list, okay, through all of these entries. So internally, it's kind of use a doubly linked list, okay, doubly linked list. Okay, so let's see the linked hash set, what specific method it says. It's basically of the hash set method that you can use, okay, and of the other abstract set method you can also use, is it? So, and the set method, but not navigable set and not sorted set method you can use, okay? Okay, so so that's all of the information regarding set. Okay, so basically we are done with set.